Hello and welcome back to another Orange Coast College Mathematics video. In this video, we're going to be talking about the Pythagorean Theorem. So first off, what is the Pythagorean Theorem? Well, the Pythagorean Theorem says that if we have a right triangle, as in we have a triangle that has a 90-degree angle, A and B represent the lengths of the smaller sides of the triangle, and C represents the length of the hypotenuse, the largest side, then we have this really nice formula that says that A squared plus B squared is equal to C squared. So, with that being said, let's try out number 1 and see how this is used in action. So, number 1 says the hypotenuse, the largest side of our triangle, is going to be 13 feet long, and one of the legs is going to be 5 feet. And I want to find the length of the remaining leg of the triangle. So first off, it's always nice to draw a picture. Okay, so now we've got ourselves our picture, and now let's move on to actually trying to use our formula. So we know that A squared plus B squared is equal to C squared. So let's go ahead and plug in all the things that we know. So rewriting our formula, we have A squared plus B squared is equal to C squared. Now I don't know what A is, so I'm just going to leave it as A squared, but I do know what B is. B is 5, so I know that this is 5 squared. And then C is 13, so this is 13 squared. Solving that out, we have A squared plus 25 is equal to 169. Now I'm going to subtract 25 to both sides to get A squared by itself. And so we're going to have that A squared is equal to 144. Now, I don't want A squared, I want A. So I can get rid of our square by square rooting. And so we get that A is equal to 12 feet. And that is the length of our missing side. So let's try it again with number 2. So number 2 says that we have a rectangle with a length of 6 inches and a width of 10 inches. But I want to know the exact length of the diagonal. Also, we're then going to approximate the answer to 2 decimal places. So first off, let's draw a picture. Okay, so we have our rectangle right here. But I want to know the length of the diagonal, this red line right here. So, how can I figure that out? Well, if I cut this in half, I really am getting 2 triangles. And not just 2 any triangles, they're going to be right triangles. So, since we have a right triangle, we can actually use the Pythagorean theorem. So, we can use A squared plus B squared equals C squared. So, let's actually write it out. So again, A squared plus B squared is equal to C squared. Now, it doesn't really matter which one you choose for A and B, so I'm just going to choose A to be 6 and B to be 10. But you'll get the same thing if you choose B to be 6 and A to be 10. It's just a matter of preference. So we have 6 squared plus 10 squared is equal to C squared. This then becomes 36 plus 100 is equal to C squared, and finally 136 is equal to C squared. Now, just like the last problem, I don't want C squared, I want C. So I'm going to take the square root of both sides. And so we come up with the answer that C is equal to the square root of 136. Now, this is the exact answer. But giving someone an answer of the square root of 136 doesn't always seem that nice. So if you plug it into your calculator, you're actually going to get that C is equal to 11.6619, and then there's a bunch of more numbers after that. But if we just want to approximate it to 2 decimal places, I can just round it, and so I say, all right, is this third number after the decimal greater than or equal to 5? No? Well, then I'm not going to change this number. And so we get that C is approximately 11.66 inches. And so we're done with number 2. Moving on to number 3, we're asked to solve for x in this right triangle. Now this one might seem a little bit more intimidating, but let's just treat it like how we've been treating the other problems, right? We have a right triangle, we have this 90-degree angle right here, and so we know that the Pythagorean theorem has to apply. So if we take this side squared plus this side squared, it should be equal to 17 squared. So let's try writing it out. So A squared plus B squared is equal to C squared. We then have x minus 7 squared plus x squared is equal to 17 squared. Now x minus 7 squared is going to give us x squared minus 14x plus 49, and then x squared is just going to be x squared. 17 squared is going to be 289. Now from here, I see that I have an x squared and an x squared right here, so I'm going to combine those terms, and so we get 2x squared minus 14x plus 49 is equal to 289. Now from here, what do I see? I have an x squared term, an x term, and a constant term. This leads me to think that maybe this thing could be factorable. If it's factorable, then I can easily figure out a value for x. So let's try to factor it. First off, I want this to be equal to 0, so I'm going to subtract 289 to both sides. So this is going to give us 2x squared minus 14x minus 240. And that is going to be equal to 0. Now I see that each term right here is divisible by 2, so I'm going to go ahead and factor a 2 out. So we have 2 times x squared minus 7x minus 120 is equal to 0. And now I'm going to use the quadratic formula on this part underlined in red. So the quadratic formula says that x is going to be equal to negative 7 plus or minus the square root of negative 7 squared minus 4 times 1 times negative 120. And then all of this is going to be divided by 2 times 1. Taking all this, we're going to have that x is equal to 7 plus or minus the square root of 529, all divided by 2. And hence, x is going to be equal to 7 plus or minus 23 divided by 2. Now this is going to give me two different numbers. First off, if I treat it as addition, so I do the plus, we're going to have 7 plus 23, which is 30. And then 30 divided by 2 is going to be 15. So our first number is that x is equal to 15. But let's check our second number. If I do the minus, we'll have 7 minus 23, as in we'll have negative 16. And then negative 16 divided by 2 is going to give us negative 8. So we have x is equal to negative 8. So now we need to figure out which one of these is the right x value. Well, let's try to think of it in the context of the problem. What am I looking for? I'm looking for the length of a side. Does it make sense to have a negative length? Well, no. So I know that it can't be this negative one. So the only option is that it's going to be equal to 15. So we get that x is equal to 15. And hence, this side would be 15, and this side right here would be 15 minus 7, which would be 8. Moving on to number 4, we have an equilateral triangle with side lengths of 10 centimeters each. And I want to find the height of this triangle. So I know that first off, right away, this is going to be 10, this is going to be 10, and then this whole thing right here is going to be 10. Now, because I want to find the height of this triangle, I'm going to cut it down the middle, because this is going to give me access to a right angle, as in I can use the Pythagorean Theorem. So when I actually cut it down the middle, I'm going to split this in half. So this is going to be 5, and then this is going to be 5. And all of these are centimeters, of course. And so I can label this height as A or B, whichever one you prefer. So now we can use the Pythagorean Theorem, so we know that A squared plus b squared is equal to c squared. And so a squared plus b, well, b is going to be 5, so we have 5 squared, and then our hypotenuse squared is going to be 10 squared, so we have a squared plus 25 is equal to 100. Subtracting 25 from both sides, we get that a squared is equal to 75. And again, I don't want a squared, I just want a. So we take the square root of both sides, and we know that a is equal to the square root of 75. And if you were to plug that into a calculator, you would get that a is approximately equal to 8.66 centimeters. And so, we're done. Well, that's going to do it for this video, and I hope to see you in the next one.